All right, let's look at some examples now, dealing with simplifying these radicals with variables involved. You know, it's not too much different here, but it's definitely another kind of concept that we definitely have to keep in mind here, okay? So we're going to go through, I've got 5 examples for you. Hopefully this helps out here. So if we look at example 1, notice how we have all variables here. So we've got 3 of them. We got x, y, and z. There's really not much we can do between them. Look to simplify. You know, they are the way they are. So we're going to treat this as almost 3 separate little problems. So again, we're here to simplify radicals, and we, you know, in order to simplify a radical, we needed to find that perfect square, right? So if I were to prime factorize x squared, just like we did with our numbers yesterday, right? Again, we know stuff's got to go inside and outside of the house. I'm going to go ahead and draw our house or a radical there. So if I have an x squared, that's x times x. Well, just like we did with numbers yesterday, we have a pair of x's. And remember, when we have a pair, right, we have a perfect square of whatever we're dealing with. That came out of the house. Okay, now that we're dealing with variables, you know, nothing really changes, okay? And actually, once we kind of get the hang of this, variables seem to get a little bit easier than dealing with numbers, because variables aren't going to change. So let's look at our y. Same thing that's going on here, right? We have y to the 10th, so we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10, right? Okay, so again, just like we did yesterday, let's pull out the pairs, right? Well, I've got one pair here. I've got another pair of y's. I've got another pair of y's. I've got another pair of y's. Oh shoot, I'm getting sloppy. And one more set of y's. Okay, and then again, let's do our z's. Notice how there's no, same thing with the x's, there were no x's left, there's no y's left. So right now we don't have anything inside of the house. So if we look at the z's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and I kind of helped this out because you maybe catch on to the kind of the pattern here. Look how many pairs of z's that we have. 1 pair of z's. 2 pair, 3 pair, 4 pair, 5 pair, 6 pair, 7 pairs of z's, right? We have 7 pair of those perfect squares of z's, and we have one little loner z kind of hanging out in the end. Okay, so now this kind of seems like a lot to do. We don't have to do this every single time. Basically, you're faced with 2 decisions with when we're dealing with variables. Is it an odd or is it an even? Okay, so if we looked at the x squared, right, 2 is an even number, right? We're trying to find out pairs, right? We want to know orders of 2. Well, 2 divided by 2 is 1. We pulled out 1 pair of x's. Okay, look at your y's. Okay, we have y to the 10th. Well, how many pairs, right? How many twosomes of those y's are there in 10? Well, 10 divided by 2 is 1, 2, 3, 4, 5. So we should have had y to the 5th on the outside, like we did when we counted. And lastly, the other option you're going to be faced with is what happens if you have an odd number, right? 15 is an odd number. Well, what we can do is we kept 1 in the house, right? We took 1 away from, you take 1 number away from an odd number, and now it becomes an even. So we take that 1 variable and put it inside the house. Now we have z to the 14th left over. How many pairs are there in 14? Well, 14 divided by 2 gives us that 7. Okay, so again, you're being asked to find pairs. If it's even, divide by 2, pull them out. If it's an odd, keep 1 inside of the house. Then we kind of go back. Now we're dealing with the evens, and we divide by 2 and move. Anytime we're dealing with variables, underneath the radical, you should have nothing bigger than 1. Okay, if you have something bigger than 1, there's going to be a pair that you can go ahead and pull out. All right, here we go. So the next 4 examples, we're going to have coefficients and variables in them. Okay, this is more or less what you're going to be faced with here. So if we look at a 34, just like we did yesterday, we need to break down 34. It's an even, so 2 times what? 17. I think 17 is an odd number, or a prime number. So again, I think it helps keep us organized if we draw out the radical. So 34 doesn't have any pairs. It's 2 times 17. Okay, so every bit of that 34 is going to stay inside the house. Let's look at our variables. We've got an x. We have x to the 4th. 4 is an even number. How many pairs are in 4? Well, 4 divided by 2 is 2. And lastly, we've got y to the 7th. 7 is an odd number, right? So we're going to keep 1 inside of the house. That's going to knock down the 7 to a 6. How many pairs are in 6? Well, 6 divided by 2 is 3. Okay, math is commutative, so it doesn't matter, what order we kind of put them in. So if we look here underneath our radical, right, we talked about 34 not being able to be broken down. The y has a exponent of 1, so he can't go any further, and there's nothing else that we can kind of collect on the outside. Sorry. Right, so that is that expression simplified in its simplest form there. All right, next example. Okay, again, you've got to break down, we can't look at this as, one giant piece. We got to look at the 27, and then we're going to look at the x to the 5th, okay? Again, we know we need it, so I'm going to go ahead and draw my house. Let's go ahead and break down 27. I think we got 9 times 3. 9 is 3 times 3, and so if I write out the prime factorization of this, 3 times 3 times 3, I have a pair of 3s, so I'm going to pull him out, and then I have this little loner 3, right, that does not have a matching pair anymore. We're going to keep him inside the house. Okay, let's look at x to the 5th. Well, 5 is an odd number, so when we have a variable that has an odd number, I'm going to keep him inside. 1 inside. That 5 now becomes a 4. How many pairs are in 4? Well, 4 divided by 2 says there are 2 pairs. All right, so it looks like the simplest form of our example here. We got 3x squared radical 3x. Awesome. Okay, now let's look at the square root of a quotient. So this is going to kind of jump back from the previous section we got out of with all your exponent rules, with the negative exponents, being able to divide the exponents. And then also yesterday's topic where we were looking at the square root of quotients, okay? So if I see this giant mess, I don't think I want to mess with the radical just yet. I'm going to look to see on the inside if there's something that I can clean up, okay? Right away, we look at the coefficients, right? We have a 40 over 2. Well, 40 over 2 does clean up, right? 40 divided by 2 is going to be 20. Remember, just because we see exponents, be careful about applying the exponent rules to everything. 40 and 2 are still, they're coefficients, right? That's not in an exponent. So we just take care of the operation that's there, which is division. Okay, we look at our x's, right? We have x to the 3rd on top. We have x to the negative 5th on the bottom. Again, I don't know if I would get super flip happy. I would just look at, what x's we have. Remember, when we divide bases, we subtract exponents. So what we really see here is we have 3 minus, right? We have top minus bottom. 3 minus the negative 5. Right? 3 minus the negative 5. 3 minus the negative 5 is a positive 8. And lastly, let's look at our y's. Well, again, I know with the negatives, you can flip them. Like we could flip this y that was in the bottom to the top, or again, just kind of applying the definition. We have 2 minus a negative 3. And remember, again, it is the top one minus the bottom one. Okay, careful with your double negative. We have a double negative here, so we're adding 2 plus 3 is 5. Okay, so if you look to simplify in the beginning, it definitely kind of helps you out. We don't have to really deal with much of the radicals that we had in the beginning. The negative exponents, we didn't have to deal with any of the flipping. Maybe they're not all going to work out this simply, but always look to simplify as much as you can in the beginning. All right, well, we're not done. We still have the radical of, we still have a little bit of a mess to kind of handle here. We still need to simplify. So just like the other examples that we just did, let's break down 20. Well, 20 is 2 times 10 and then 2 times 5. Again, something I do to help keep myself organized, go ahead and draw the radical bar. You know you're going to use it, write it down. I've got a pair of 2s. And I've got a 5 that's going to hang out inside of the house. Moving on to a variable. I have x to the 8th. 8 is an even number, so all I'm going to do is divide by 2. 8 divided by 2 is 4. Remember, it's an even number, so nothing's going to hang out in the house. And now I'm left with y to the 5th. 5 is an odd number, so one of them is going to stay inside of the house. That's going to leave you with y to the 4th. 4 over 2 tells you have 2 pairs. All right, and again, we have nothing out here that's, like terms, nothing we can collect, nothing we can simplify further. 5 is a prime number, and y, remember we talked about variables. The biggest variable you should have in is just a power of 1. All right, so we have something that kind of looks like a big giant mess. Don't try to dive into, looking at it as a whole. Take it piece by piece, like I said, try to simplify as much as you can. You've got the skills to be able to do it. Just take your time and break it down that way. All right, so let's do one more example with this kind of stuff. These things are very tedious. They're annoying to do. But really the only way you do get better at this kind of stuff is you have to look at examples of them and you kind of have to practice at it. Watching me do one, you do one, you're not going to be able to really understand what's going on, okay? Getting involved, kind of jumping into it and doing as many examples that as we can is truly the best way that we're going to understand how to do this stuff. All right. Let's break down this guy. Again, I'm going to look to clean up any of the stuff that I can. And I have the 8. This has a coefficient of 1, so that's really not going to change anything. So we have an 8. I have 2 x's on the bottom. I have 2 x's on top. I have 6 x's on the bottom. So one way to think about this is to look, where are there more of the variables? And there are more on the bottom. How many more of them are on the bottom? Well, there are 4 of them. Or the other way to look at it mathematically, what you're doing is 2 minus 6, which is -4. Remember, when we have a negative exponent, we flip it, right? So this is the same thing as saying x over 1. Now we flip it to the basement, which is why we see x to the 4th down there. And lastly, we have y to the 4th over y. Same thing. We have top minus the bottom. 4 minus 1 says we have y to the 3rd. All right. Well, we still have a fraction involved. The last example that we looked at, the fraction cleared, which made things a lot easier. Well, remember, one of the first things that we discussed with this is we have the square root of a quotient. The quotient rule tells us we can have the quotient of our square root. So what I'm going to do is I'm going to separate this fraction into 2 separate radical signs, okay? So the top, I have the 8y to the 3rd, and then the bottom, I have x to the 4th, okay? This makes things a little bit more manageable for us. Okay, again, we're not looking at one giant fraction. We separate them out to make them 2 smaller fractions and more manageable to handle. Cool. All right, let's get into it here. So we've got an 8. Let's break down the 8 here. 8 is 2 times 4, which is 2 times 2. And with that, we've got a pair of 2s and a loner 2 that's going to stay on the inside. All right, we have y to the 3rd. 3 is an odd number, so I'm going to keep 1 in. 3 to a 2, how many pairs are in 2? 1 is going to come out. All right, and then let's look at the bottom guy here. We have x to the fourth. 4 is an even number. 4 divided by 2 is a 2. So a lot of steps, you know, everything that we've kind of done for the past two sections, 3.1, and now this is the end of 3.2. That problem pretty much had all of it. You had to do your exponent rules, you had to simplify a number, you had the quotient property, you had to simplify radicals with variables. So this is about as tough as they come. Moving forward from this, I don't think they're really going to get much more difficult with that. Understand that it's still an expectation to be able to do this, but you're going to see a lot of the other stuff, the other examples that we just kind of looked at. Okay, like I said, very tough example. Don't freak out if you really didn't get that one too much, but you know, this is on a video, so you can go back, replay it, slow it down for whatever need you have there. All right, so this will now conclude section 3.2.